Hello, everyone. This is You'll Be Blessed here, making it clear, making it plain, opening up the heavens. For my teaching is like spring rain, bringing it to you and understanding the periodic trends, specifically in electron affinity. Today, you're going to be able to describe the trends in electron affinity in order to discuss the effects of the subatomic particles on the chemical properties of elements. All right. And the concept here is that if you understand the interactions between the particles, then you'll see that they exhibit patterns. So let's begin today's lesson. Electron affinity. The definition of electron affinity is actually the energy released when a neutral atom gains an electron. So you start off with a neutral atom and you add an electron to it. And what ends up happening is that this electron becomes a negatively charged particle or a negatively charged ion called an anion. And the result is you release energy. This is actually the opposite of ionization energy. And so the property is a little bit different also from electronegativity, if you've heard of that before as well. So here's a pictorial form or a graphic form of electron affinity. Basically, this is chlorine. You have the neutral atom on the left, and then on the right, you have the chloride ion, which in which this ion has received its eighth valence electron, a new electron from a different atom, and it's excited to get this electron, so therefore it releases energy. And electron affinity is like receiving a gift that you want for your birthday. Okay, as you can see, SpongeBob to your right, he is actually very excited about something that he sees. And so basically, when you get a gift that you really, really want, you are typically excited and you release this excitement with a bunch of energy. It's an expression of excitement. All right. But then there's another side to electron affinity because, a lot of people do like to eat food. And if you've seen this movie, Matilda, okay, there's the young boy here who ate the Miss Trunchbull's chocolate cake. And, you might be excited to eat that chocolate cake when you first begin eating it because it's so delicious. But after a while, when you become full, you're not as excited about eating the food or eating the cake because, you're just at the point where you're just full. And so atoms can be the same way. They can be excited to receive electrons, but once they become too full, they're not so excited about receiving electrons. And so that's what electron affinity is all about. So now let's look into the actual trend. Okay, so electron affinity across the period. That's what we're going to look at first. Okay, so electron affinity increases as you move across the period. And why? It's because atoms love having eight valence electrons. So as you move from left to right, you start with one valence electron and then you go to eight valence electrons. And so the closer you are to having eight, then the more excited you are to receive that electron because you're so close to receiving that perfect octet. But then also, the reason why electron affinity increases from left to right is because of the addition of protons. As you increase the atomic number from left to right, you're increasing the nuclear charge, and therefore there is a natural tighter pull on the electrons. There's a greater attraction for electrons. Okay, let's dive into some examples. So, which of the two atoms has a lower electron affinity? Is it calcium with an atomic number of 20 or um, gallium with an atomic number of 31? Which one would you choose? If it were me, I would choose calcium. And the reason why calcium has a lower electron affinity is due to one of these following reasons. Which one would you choose? If it were me again, I would actually say that calcium has a lower nuclear charge than gallium. So these two elements are in the same row on the periodic table. So we're talking about electron affinity across the period. And because calcium has fewer protons, it has a lower nuclear charge than gallium. And so there's a less attraction for having those electrons or receiving an electron. It's not going to be as excited to receive one. Okay. Let's look at our next example. Which of the two atoms has a higher electron affinity? Is it going to be lithium or is it going to be fluorine? Which one would you choose? I would choose fluorine, all right, with an atomic number of 9. And so then why would I even choose fluorine over lithium? Again, these two elements are in the same row across the period from each other. All right. So therefore, because fluorine has more protons, we're looking at a higher nuclear charge, and therefore it is more excited to receive extra electrons. Also, one of the reasons why it is actually not listed here, but fluorine is only one electron away from having an octet. Okay, so let's continue to move on to the next periodic trend. All right, so now moving on to electron affinity down the group. The electron affinity decreases as you move down the group, and this decrease is actually very, very small. Okay, so why? Why does this happen? Simply because as you add more energy levels, the energy levels actually repel valence electrons, which is the electron shielding effect. And the result is that you're just not as excited about receiving electrons when you have so many energy levels or such a high degree of electron shielding. Okay. So again, it's like eating too much cake again. You've had too much, you're not excited about having more. All right. So let's dive right into the next example. Which of the two atoms has a lower electron affinity? Is it cesium with an atomic number 55 or potassium with an atomic number of 19? Which one would you choose? Now, if it were me again, I would definitely choose cesium. So, why cesium over potassium? Well, cesium and potassium are in the same group, so from top to bottom. And actually, potassium is on the top, and then cesium is at the bottom of the periodic table. And so, because it is further towards the bottom of the periodic table, it actually has more energy levels. All right. So, because there are more energy levels, it is repelling the valence electrons. Therefore, it is less excited about receiving an electron, an extra electron. Okay, compared to potassium. Next, we have which of the two atoms is of higher electron affinity? Iodine with an atomic number of 53 or chlorine with an atomic number of 17? Which one would you choose? And I would end up choosing chlorine, having the higher electron affinity. And why would we choose chlorine? Well, it is simply because chlorine has less electron shielding. All right. Again, these are two elements that are actually in the same group on the periodic table, with chlorine being on the top somewhere, and then iodine being on the bottom or somewhere near the bottom of the periodic table. Chlorine has fewer energy levels. So this is cesium. I'm sorry, this is excuse me, this is iodine having multiple energy levels, and then this is chlorine having fewer energy levels, and therefore there's less electron shielding. And it is more excited about receiving an extra electron. Now, both of these elements should be excited because they are one away from a valence electron, but the primary thing is that there's less electron shielding again. All right. So this is a recap of the electron affinity. As you can see, again, the dark regions on this chart represent elements of high electron affinity, while the light regions represent elements of low electron affinity. And so the white regions also express that these elements do not have a value, or their values have not been measured. Okay. And let me give you one more question just so that you can um, understand some of the exceptions to this particular periodic trend, because it is a little bit trickier than some of the previous ones. So in this last example, we're determining which of the two atoms has a higher electron affinity. Is it going to be neon with an atomic number of 10 or bromine with an atomic number of 35? Which one would you choose? I would end up choosing bromine. Now, hold up. Bromine, why bromine over neon? Well, let's compare the two elements. Bromine is actually in group 17 on the periodic table, and then neon is actually in group 18 on the periodic table. In addition, bromine has more energy levels than neon. So this is a little bit different. It actually breaks the pattern or breaks the trend where the electron affinity actually increases from left to right. And so the reason why bromine has a higher electron affinity is because it's missing an electron, and neon is primarily content with already having 8 valence electrons. So it is not going to be as excited about receiving an extra electron. And that's the thing about the noble gases that I want to leave you with, is that the noble gases, all of them, are content with their 8 electrons. Okay, so it's going to be very difficult to convince them to get more, and they're not excited about receiving more. So they are actually considered a deviation from the trend. So the electron affinity increases from left to right across the periodic table, but it drops again when you get to group 18, the final group on the periodic table. So that concludes today's lesson, and I hope this was clear for you. Thank you for tuning in to You'll Be Blessed Education. I hope you were blessed by this video, and if so, then I highly suggest that you click on the like button below, as well as subscribe to this channel so that you can receive future updates on content. Thank you, and have a blessed day.